Right, this is the second interim test feedback. I'm going to make this pretty brief. The mark scheme is at the end. I'm going to point out some really important things and a bit of a technique of how you can perhaps decode some of the questions that you found hard. Key to this question here is picking out the word other and then making sure you don't include a protein. So some people put enzymes, some people put hemoglobin, they're proteins, so they couldn't be an answer. Other polysaccharides are fine, glycogen or starch, because it doesn't say other than polysaccharides. This is a 2-mark question, so simply the fact that a buffer controls the pH, so the pH doesn't change, isn't enough for 2 marks. The second mark is, so, well, why is that important? Well, it's important to keep the reaction going at the enzyme's optimum pH, or to stop the amylase, which is the enzyme, from denaturing. This question down here, where we've got the Biuret test, I'll be annotating this. Biuret test, testing for a protein. So where's the protein in this? Let's look at the information. We've got the enzyme amylase, which is a protein. Now, why would that be found when the sample's finished, after you've finished breaking the starch down? Well, an enzyme, because it's a catalyst, isn't used up, so it'd still be found in the solution at the end. So that is why it would turn lilac or purple. It's really important with comprehension questions that you annotate as you go along. Annotate before you answer the questions, then annotate again after you've read the questions. So let's look at question 1. So name the monomers that make up the enzyme, the active site of an enzyme. We need to make the link that an enzyme is a protein. Again, annotate, and the key bit is name the monomer. So the monomer for a protein is an amino acid. The question down here is pretty tricky. So this one really is pretty hard. But use information from the text why aspirin doesn't affect any other enzymes apart from one of them. And it says here that aspirin attaches to a group in one of the monomers, so it's binding to one of the amino acids in the active site. So the amino acid will only be found in one enzyme's active site and no others, so it can't bind to any others because the amino acid is simply not in the active site for those. Looking further down, this question, which enzyme X, Y, Z is inhibited by aspirin? It does say you've got to use information from the passage. So to use information from the passage, a bit highlighted in orange. So this enzyme that aspirin attaches to is also involved in the pathway leading to the production of prostaglandins and thromboxane. So the only enzyme that's involved in both prostaglandins and thromboxane, it can't be Y, that's only involved in producing prostaglandins. Can't be Z, that's only involved in producing thromboxane, so it has to be X. So this step is involved in both pathways, the pathway that produces prostaglandins and the pathway that produces thromboxane, so it has to be X. There was a mistake, a lot of people put in this, it mistook aspirin for being a non-competitive inhibitor. The information for the text where it says that aspirin binds to one of the monomers in the active site indicates it's a competitive inhibitor, it's fitting to the active site. So any marks to do with non-competitive inhibitors would not be given. This question was a mixture of 2. The first part was answered absolutely fine, but the second part wasn't. So why does an enzyme allow reactions to occur at colder temperatures like in our body? Well, it's got to be to do with the enzyme being a catalyst and it lowering the activation energy, but how does an enzyme do that? And it's all to do with the induced fit model. So the fact that the induced fit model forms, when it forms an enzyme substrate complex, it's putting strain on the bonds in the substrate. The fact that it does that means that it's lowering the activation energy. On the whole, this question was answered well, but a couple of key mistakes. First of all, you can never say that a substrate is the same shape as a competitive inhibitor. A competitive inhibitor has a similar shape, not the same shape. Another big mistake in this question was that a competitive inhibitor does not have a similar shape to an active site. It has a complementary shape. They fit together. They don't look the same. They fit into each other like a jigsaw. Always annotate your graphs. So if you're looking for differences between curves, look for gradients, peaks, troughs. You can quite clearly see that we've got a steeper rise, a higher peak, a faster fall, and this drops below the line, and this one always stays above the line. Underline on the end of each thing because it's a comparison, so in comparison to the other line. Also, for the other question, why does white bread have what the high GI? Well, if high GI food's got more sugar in it, so it's more rapidly absorbed. You're just using information from the text. So here are those questions from the graph before. Model organisms are important. You have to use model organisms if you're doing drug trials, if you're seeing if something you're giving to something causes certain kinds of disease like heart disease or cancer. You can't use it on people, those things on people because of ethical reasons. So model organisms have to reflect the effect that it would have on human. You'd have to be able to say that because this effect is happening to this animal, it's going to be similar in humans. So why is that? Well, we're both mammals, both got similar physiology. For some things, the fact that mammals, things like rats, grow older faster means that you can look at long-affecting illnesses, the effects on long-affecting illnesses like heart disease and cancer, much more easily than waiting for decades in a human. So lots of reasons you'd use model organisms. Also in biology you need to do lots of samples because of the variation in the data to be able to prove that what you've got is having an effect. So the fact you're using cats, rats, anything like that, you can use a lot more organisms than you could with people. Again, always annotate your graphs. Standard deviation, you're looking to see if standard deviation bars overlap or not. You can clearly see that these standard deviation bars do not overlap. So that means the vast majority of the cats that took formula milk had a lower mass than the vast majority of cats that took formula plus lipase. So there is a significant difference because there's no overlap, indicating that lipase is having an effect. Whereas there's no overlap between lipase and breast milk, which also does contain lipase. So there's not much of a difference, even though the bars are different. The standard deviation bars overlap. So there's quite often cats that took this had a higher mass than cats that took this. Not always, because of the average, but quite a few of them did. So that means that breast milk does not significantly increase the mass compared to lipase plus formula. This question, you often get questions where you have pictures of molecules, but it's no different to if this were the substrate and if this were the shape of another molecule. If that's the shape of the substrate, this is similar. That bit would fit into the active site, like this bit fits into the active site, but it's not the same shape, so it's a similar shape, so this is a competitive inhibitor. And then the mark scheme writes itself after that. Need to know the difference between describe and explain. It's quite a simple skill to master, but it's still often got wrong. So describe is simply what is the line doing. It's increasing up to an optimum of 30 degrees, and then the line is decreasing. That is a describe. They explain between 30 and 50, explain, so basically why, not describing, but why is the line decreasing? It's decreasing because the enzyme is denatured, hydrogen bonds are broken, the active sites change shape, the substrate no longer fits, fewer enzyme substrate complexes formed. That is why the line is decreasing. And here is the mark scheme which you can use in your own time. If there are any questions about any of these, please remember to come and ask you.